briefly. What I want to deliver to you guys today is a very practical session on how you can utilize Python for basically reservoir engineering. There are lots of aspects of Python, and one of the most, let's say, helpful aspects, especially for petroleum engineers or people working in subsurface domains, is actually how practical and how applicable Python can be and how relatable it can be to the daily workflow. So, without further ado, let's go ahead and start the session. Although we also have some people are joining in, so let's start. By the way, feel free to ask any question while I am delivering this webinar. Okay. First of all, I would like to thank PA for sponsoring and organizing such events. Since 2022 or earlier, we have been working with PA on regular basis, and we have successfully delivered more than 30 webinars, and most of these webinars are free. You can find those on PA's YouTube channel. So that's a good starter if you want to know what we've been up to in the past few years. So we all hear about Python, and most of you guys know, or at least hear of someone, maybe your colleague or maybe someone you know in the company you're working with, or in some other companies, or maybe on LinkedIn, you see those people are using Python, and basically they are utilizing Python for different things. For example, reservoir, petrophysics, production, drilling, and some people even go extreme to use Python on some of the administration tasks that even HRs can do. So lots of users have been, let's say, invested in Python. But what is the fuss is about? Today you will understand why Python has gained so much ground in oil and gas industry and why basically it's growing so fast. It's going to be one of the demanded and required skills in the upcoming years. So before we go ahead and see that, let me show you why you should consider taking a training with us. Uh, PA is the leading digital learning and training provider for the energy sector, not just oil and gas, coal, steam, and renewables. Plus, we have been creating innovative trainings, especially data stack trainings related to Python in different domains. We have 99% satisfaction rate, and I am not exaggerating that, by the way. Um, uh, what drives our trainings and why our trainings is very different from the other providers? Well, the trainings are delivered by industry professionals like me. So before being a programmer, I am a production and a flow assurance engineer. So first of all, I am a petroleum engineer, and then I am teaching Python. So that's a combination that you should look for someone delivering these types of trainings, because you don't care about the theory of Python. You don't care about the theory of the programming. What you need is how practical it can be, how relatable it can be to your workflow. Otherwise, it's just a waste of money. Plus, the training materials and the training examples we are creating are premium. They are not found online. Everything, every example, every plot, everything that you will see in our trainings, and this applies to all of our trainings, are created 100% by us for you guys. By the way, Mr. Nakhil, now the Zoom meeting or the Zoom link is full. Please make sure that you open up the YouTube channel so people can also watch from there. Thank you so
Sure.
much. Okay, so let's start with a question that you might have yourself. That's why maybe you're joining this webinar session. Why do you need to learn Python, especially for reservoir and petroleum engineer? Well, there are many answers to that. The answers to that are usually countless answers, but most of these answers are relatable to one person's, for example, experience. So this is a very subjective answer is usually going to be. But I have managed to collect some of the answers that are people they are looking for or people they seek whenever they try to learn Python. And let me share some of the answers for you. We all know that oil and gas industry has been working and crunching data from the past, let's say, 19 years, especially whenever we started converting those hard-earned data to correlations, or let's say equations that we are utilizing on regular basis. And specifically, I am talking about productivity index and back pressure equations, because these are one of the most, or sorry, these are the oldest equations that we usually have, and those are based on hard-earned and collected data. However, now with Python, you have the ability to innovate and add new types of analysis to your work. And this can be done using machine learning, clustering, artificial intelligence, statistical analysis, variance analysis, and different types of things that you can do in Python. And I am not saying that these are not possible in Excel. Well, most of these are possible in Excel, but they are very, very limited. In Python, it's just taking these solutions to another level. Plus, what happened is, um, in the 90s, or in the mid 80s up to the early 2010s, what we have been doing, especially in oil and gas industry, uh, this is majorly speaking, does not apply to 100% of engineers. What we have been doing is we have let um, software companies to take control of our workflows. We can see that from the mid 80s to the early 2010s, well, everything that we did, especially in the large operator companies where the profit is too high, we see everyone is using commercial software. The commercial softwares are great. Commercial software, they make things easy. They tend to actually to utilize a guided workflow. But what happens if an engineer wants to create something of its own? Maybe he wants to devise a new way. Well, the only way that engineers used to do that was using Microsoft Excel, and Microsoft Excel can get messy very, very fast. Other people even used MATLAB for this. I don't know any colleague of mine that's using MATLAB on any of the oil companies that we have operating worldwide. Anyway, Python can help you in that area. It can help you to do lots and lots of work. And the good thing about it, Python is now approved on most operator companies. You can download Python and start using it without the hassle of introducing a malware or introducing some kind of virus to your machine, because it's open source and it's free. Plus, using Python, using some advanced visualization, you can create and deploy and basically apply different monitoring technique and engineering techniques in operations, basically applied on wells, equipments, and basically different assets that we have in oil and gas industry. Plus, nowadays, we can also see companies that are basically heading towards Python, which is basically integrate Python for the full cycle development. And we can see nowadays, especially with PyVision, the OZPy servers and different PTX technology, we can see these components are basically utilizing also Python can be utilized to basically make everything connected. Um, Other softwares, they are also providing Python, but this is something that we will see in the upcoming slides. So just important thing to note is Python now is basically allowing you to integrate everything together. One of the things that I really, really love about Python is the ability to learn it and transfer your knowledge. So what does this mean? We all professionals are in oil and gas industry. So each one of us has his own domain or her own domain working in. For example, we have people working in petrophysics. We have people working in reservoir simulations. We have people working on water injection teams. But the problem is with these domains that we're working with is the tools, or let's say the methods that we have devised are very specific to those tasks. So it's really, really hard to transfer these knowledges to other industries because those are ad hoc, or let's say fit for purpose methods. Especially the tools that we are using, they can hardly ever translate, especially if you're thinking about petrophysical tools. But in Python, if you learn Python and you learn the concept of Python and how can it basically used and connected to different data to drive different solutions, well, You only have to learn it once. You will learn Python once, and then you can apply it in many, many industries. Any industry you want. You can apply it in finance, you can apply it in food and manufacturing, you can apply it in car industry, in automotive industry, sorry, you can apply it in energy, you can apply it in renewable, you can apply it anywhere you want because it's a general tool applicable anywhere you want. Now, hopefully that was not too long why you need to consider Python. Now let's start seeing why Python has gained so much ground. By the way, by no means Python is a new programming language. It was invented in, or sorry, it was created in 1991, and 1991 is not considered as actually, it's not considered new. It's actually, we can consider this as a modern, but it's not new. Python, during these 34 years, has got so much support that it has basically skyrocketed Python's popularity immensely. People started using Python for everything. And I am speaking everything that you can imagine. People are creating website with it. People are creating full-fledged softwares with it. Um, one of the most infamous softwares that we use in oil and gas industry is based solely on Python, which is Techlog. Techlog is based on pure Python technology. People use it in mathematics and in academia instead of MATLAB because, well, it's free. MATLAB is a paid software. People use it for system scripting. Basically, people use it to automate things. This is what a system scripting is. And majority of the Python usage, which is something between 60 to 80%, lies in data science. Data science is just a big umbrella that hosts lots and lots of domains and topics. This can be machine learning, artificial intelligence, data exploration, data mining, statistical analysis, anything that you can think of basically relies on data science. And typically, data science usually relies on Python up to 90%. Plus, we have also seen some companies doing some engineering consultation and design using Python. For example, there are some companies using computational fluid dynamics or CFD packages that are open and free. Basically, based on Python, they are basically using this to design and basically create the drafts and simulations for different components and equipments. This is purely using Python. You can see there's like a huge spectrum of Python usages. Now, why Python has gained such a ground in oil and gas industry, and basically in any industry to be precise. First of all, there is large and large number of libraries. So let's just that sink in. What does a library mean? Well, just think of it. What is a library? Why do you need a library in the first place? Well, a library is something that you write and let other people use. So what does this mean? So the effort that I am going to put, for example, let's say I am creating a code to calculate the bottom hole pressure, right? Maybe I will use it in the future for rate transient analysis. The code that I am going to write for this bottom hole pressure, I can easily share it as a library. You guys can use that. Anyone in the planet can use that with an internet access. You will install it on your machine with a single and easy step. Once that's installed, now it's on your machine. So the effort that I have put into writing this code that calculates something for me or does some sort of analysis, maybe let's say that I have put 100 hours on this. Maybe it took me 1 month to do. So that 1 month effort, you don't need to go through. You can just utilize that directly. And this is the concept of library. It's a way to share code and share effort between people. Let me show you something. If you go to Google and search for Python package index. So what is a Python package index? This website basically is the main website that hosts all the Python, let's say, codes and all the Python projects. Typically, a project is usually related to a library. So let's say that this is not the case here. If we take a look at, we can see in this website, Python contains almost 600,000 projects. If we say that only 10% of these projects are true, then we have 60,000 projects or 60,000 libraries that are usable on your computer right away. You can imagine how many people have contributed to this project. By the way, each month, if you pay a visit to this website, you will see this number of libraries are growing, and they are growing very, very hugely. So the idea or the concept that we learned in the 80s, 70s, where we write code and we do everything manually, well, in the modern days, that's not applicable anymore. Python nowadays makes everything simple. If you want to do plotting, well, that's great. In the 80s and the 70s, people, they wrote those things from scratch. In Python, now it's just a single line of code. 15 years ago, if you wanted to read an Excel file, you have to write the file parser yourself. By the way, the code that reads a file, it's called parser. You would write that, and it usually takes like 100 up to thousands lines of code. Well, nowadays in Python, it's just a single line of code. And you can see how that can immensely reduce the effort. So that's number one, which is the large libraries. Plus, we have a big community. A big community is basically whenever you have lots of people using Python, well, you have big community. So basically, the problems that you will encounter, maybe someone usually have solved that problem before you. So that's what a big community is for. Plus, Python is free. It's open source. We have already got to this. Plus, it's easy to learn once you know the proper path. So that's conditional. Plus, Python is easy to share the code. So the older folks that we have and the senior folks we have in this webinar, they all know that in the 80s, it was really, really hard to share codes between computers because different computers had different versions of programming language. And this is basically was applied to Fortran and BASIC usually. So in order to convert the code, or let's say in order to transfer code between colleagues, it was just a pain. And you only had one option to do this easily, is to use the same exact computer with the same exact CPU and the computer architecture. Nowadays, well, everything is different nowadays. I can write Python code on my PC, which is Windows, and I send it to you, over to you, and you can run the code on your iPhone, and you will get the same result by the way. So because Python has a single architecture, and basically it works on every single device without changing anything. Plus, one of the things that I love about Python is they have, or basically it has good number of libraries that are supporting oil and gas industry. We have lots of free tools in Python. We have something basically, a category of tools we have, it's called IDE, or Integrated Development Environment. This category of tools basically allows to write code. And luckily for us, all of these exist, and great options we have in Python. In Python, we have Spider, we have PyCharm, we have Visual Studio Code, and basically all of these are free, and you can use it right away. Usually in our training, we usually use Spider, but our trainees, sometimes they are a little bit more advanced than the others. They use other options alone. Plus, there was a leap forward in the previous years. Now, you don't have the option. If you don't have the option to install Python on your machine, maybe you're working on some secret project, and maybe your company does not allow you to install some particular software on your machine, well, that's okay. Now you can use an online version of Python. We have lots and lots of options for this. For example, we have something called Colab, which is by Google. We have something called GitHub Code Spaces, which is by a very infamous website, which is called GitHub. Plus, we have Visual Studio Code, which is an online version of the same application that we have in the desktop. So there's basically no excuse nowadays not to learn Python, because everything now is possible, fortunately. Now, let's see which companies had made the leap and started converting their solutions into Python. Now, the open part of any particular application, so that can be oil and gas application, chemical engineering application, any application you want. The open part of that particular application is known as API, or Application Programmable Interface. And large number of software providers in oil and gas industry started to offer that. We have one of the leading companies that are basically transferring towards Python is Schlumberger. We have Techlog, which supports Python. So if you know Python code, you can easily inject your Python code into Techlog and basically make Techlog do things that it cannot do. We have same thing for Olga. Pipesym also supports and integrates with Python greatly. So if you know how to write proper Python code, you can utilize Pipesym. You can inject code into Pipesym. You can pull results from Pipesym, or even you can link Pipesym to MBal, which is basically not possible, but you in Python you can do that. If you know Python, you can use all the packages that we have coming from Petroleum Experts, which is the IPM package. You can use it for GAP, you can use it for Prosper, you can use it for MBal, you can use it for PVT package. All of these things can be done and can be integrated with Python. You can use it also for Geolog, for T-Navigator, and other softwares are also hopping in. For example, CMG, we have seen CMG also in the recent years, they also added a way to control the simulation using Python. Many software companies are joining in and integrating Python because it's easy. It does not require a lots of training from the software company side. Plus, lots of people they already know Python, so that's basically why it's logical for lots of companies to shift to Python. Now, let's see what examples that we can do in Python or what things that we can do in that Python. By the way, whatever you see in this webinar is just a sample. It's no way a comprehensive list of things that you can do. Basically, if you learn Python the proper way, well, the sky is your limit. You can do anything you want. So in the engineering side, you can create PVT calculations, you can create and design well tests, you can simulate well tests, you can do lots of things, and you can create or you can basically create forecasts and predictions using decline curve analysis. You can create fracture designs. I even know some people who basically they invented their own way to calculate fracture width and the fracture propagation. So that's also a possibility. I see lots of people using Python for petrophysics and basically integrate that with smart solutions like machine learning and artificial intelligence. And one of those people is Andy McDonald's. You can find his channel on YouTube, or you can even pay a visit to his LinkedIn, and you will see lots of useful posts on Python for petrophysics. You can also use Python for surveillance. In my opinion, using Python for surveillance is one of the best things that you can do in reservoir engineering, because surveillance is so wide category of different plots and different diagnostics. Python can be very flexible. You can use it to create anything you want. Basically, some things that are not possible in commercial packages, for example, advanced visualizations. Those does not come to these types of commercial softwares very easily. And you have to wait for the company to basically create that feature for you. But in Python, you can implement and have those features. By the way, did I tell you that Python now has the capability to create a dashboard, a full-fledged dashboard, just in just 1 or 2 days, uh, depending on how good you are in Python? Once you create that dashboard, not just you can utilize your dashboard alone, but you can also share that dashboard real time with your colleagues that are basically utilizing the same network as you. So that's also a possibility. This is something that we have been teaching our participants from day one. Plus, in Python, you can also do simulations. You can do one-dimensional reservoir simulations. You can do material balance. In material balance, you have few options. You can create or you can use ready-to-use material balance software, which is a tank model, or you can basically connect MBal to Python. This is also a possibility. Let me show you another example, which is something that we will be doing today, which is a calendar heat map. A calendar heat map is something that does not exist in commercial softwares. A calendar heat map is just your typical calendar, but this calendar is colored depending on any particular KPI that you want to monitor. It can be oil production, gas production, water oil ratio, a developed skin factor, reservoir pressure, anything you can think of. Maybe you want to monitor the wellhead temperature. Maybe you want to observe some seasonality that's happening during different seasons. Well, that's a possibility. This is only possible in using languages like Python. By the way, whatever tool or whatever visualization that you see that we are doing in Python, the library for that particular visualization is going to be 99.9% is going to be free. So you don't have to worry about these tools because what we teach is going to be all open source and all free code that you can get. Another example case that lots of people are using in Python is the ability to calculate full-fledged PVT relationships based on equation of states. Luckily, in Python, we already have packages that are created for equation of state calculation. We have Ping and Robinson, we have RKS. Basically, we have different things. What you need to do as an engineer, you only need to feed what components that you want to do the simulations for. And do you know what? We already have a package for that. You don't need to program those properties on your own anymore. We have packages like chemicals. Those chemical packages basically contains a really, really, really large database of different components. You can just utilize those directly and basically inject those into equation of states. You will get a plot that is similar to this. Basically, it will show you the different relationship between volume, temperature, and pressure. Plus, one more example that might be simple, but it's not possible to do in commercial software, which is the ability to create 4 or 5 dimensional scatter plot where you have different two axes, you have different colors, you have different shapes, and you have different sizes, and all of these are controlled usually by the person who is creating these types of solutions. By the way, whatever you see in Python, it can be either static plots or it can be interactive. You can choose whatever you want. This is the end of the slides or the presentation, and hopefully it was not boring. Now let's start with the practical aspect. Meanwhile, if you have any question, please feel free to ask. Okay, so now before I show you some code or before I show you something to write, let me show you some solution that we have done 2 months ago with our participants that were joined for the previous reservoir engineering training that we had on Python. So basically, I will show you two versions of a similar tool to create decline analysis or curve analysis or data fitting analysis. Well, you can name it whatever you want. This is a very classical way on creating decline curve analysis. And this is basically, this solution was done using Python. If you're interested, I can also show you the code. Basically, what is the purpose of this Python code? The purpose is to find the different decline components, which are the DI, BI, and the initial flow rate, which are those are experimental numbers that you have to try and error to find the best fit. Okay, so basically, we have created a Python code that automatically calculates for you and basically it's interactive. Let me show you. This is a single well. We have selecting. We can switch to another well. Once we do the switch, well, basically the equation is solved again, and basically those fitting parameters are calculated. Let's select another well. There you go. You can see once we select another well, different decline components and different solutions are found for the decline equation. Not a lot of people love this. Well, because but this is usually the standard in oil and gas industry. Some people love to control this, and they love to control this in a great aspect, in an aspect that sometimes even the commercial softwares do not allow you to do. Let me show you. We also have a solution that we have created 2 months ago, which is the ability to create linear forecast for Python. And these linear forecasts will also include the price of oil. So you can basically generate how much oil income that you're going to get in the upcoming months. Let's say that you're interested in any component. Let's say maybe you're interested in water. Usually waters are going to be negative cash flow because you have to pay amount of money to dispose these waters. So creating forecasts for these are also possible. First of all, let me show you how we can create a forecast for oil, and then I will show you how we can create a forecast for water. This is just a linear forecast, but it can be anything you want. It can be non-linear, it can be exponential, it can be polynomial, it can be a function-based, it can be anything you want. The concept is the same. So let's say we want to forecast based on a particular region on our data. What you're seeing below is the sample data. So let me show you the different ways we have to select data. And by the way, this is all viewing real time, and basically it's fully interactive in Python. Let's say that we're interested in only the later version of the data. So what we will do, we will select a box and we are going to highlight only this region. Once we do that, we are going to get a forecast, and this is the forecast schedule. By the way, the line is there, but for some reason it's white. So let me switch the view to dark mode. There we go. Now this is the forecasted line, and the white one is the fitted line. So the yellow one is the forecasted line. And this is basically based on the data that you have selected. What you can do is you can even manipulate the data that you have selected. Once you do that, you can also see that this is the type of fitting you get. Let me show you something else. Maybe you don't want to fit the data like a rectangle. Maybe you want to fit your data based on a particular range of selection that you're only selecting based on your judgment on this topic. So let's say that we're only going to select the smooth version of this data. So this can be done by using a tool called a lasso tool. A lasso tool is basically a tool that you can utilize in order to create selections, and those selections are facilitated by Python. I did not program this tool. This tool existed in Python. What I did is I only utilized it for my own benefit. And there you go. You can see this is the selection that Lasso made. Let me show you one more thing. You can even modify those single points on these lassos. Using this lasso tool, which is extremely powerful tool, you can refine, you can apply, you can create any type of forecast you want. Now, this is for oil. And basically, whatever forecast I am doing is I am calculating the daily rate, and sorry, this is the monthly rate, and plus I am calculating the cumulative, and I'm also creating the cash flow depending on how much price of oil I have used in the code. By the way, you can also make the price just available to the user for the to change. Let's say that I want to create an unorthodox forecast. For example, let's say we want to create a water production forecast. Water production forecast is one of the trickiest things that we usually do. But let's say that linear application, or let's say linear forecasting, does apply on one of our wells, but this is usually not true. Let's select one well that exhibits linear trend. So let's say that we want to forecast this well. What we will do, we will create a lasso selection, and based on this lasso selection, we are going to get this water forecast. And you can, of course, pan it, you can even zoom it. And the most important thing is you will get the cumulative production, plus you're also going to get the negative cash flow, which is associated with water. But this is the price has to be adjusted for the proper values to be shown up. These are just ready-to-use solutions that we have done in the previous training sessions. Now, let me show you some practical code that I will guide you through on how to write, which is going to be 100% coded in front of you. Please let me know if you find these interesting so far. Okay, so now let's start writing some code. And by the way, I promise you the code is not going to be very long. It's going to be intuitive, and it's going to be fun to see, by the way. By the way, you can make this as complex as you want. So first of all, this software that you see is just the tip of the iceberg. Python has many, many softwares that you can write code in. This is one of the recent softwares that we're actually using in our trainings, in the future trainings, which is called Marimo. You can use any software you want. By the way, every software that you see we are utilizing, it's 100% free. Now, let's start with something. We will create the same calendar plot or the heat calendar that you have seen in the previous example. So first of all, what I will do is I will create a data read. So what is a data read? So this is the code that's responsible for data read. Basically, we have a library called Pandas that reads or facilitates reading data. We have another library called Plotly. And basically, this is the file that we're reading, and this is the data source for our file. So let me show you what this data looks like before we even go ahead and dive into it. And we don't need to, by the way, to open that file externally, because you can also open that file inside Python. So let me show you. So if you type data just like this, which is the name of the variable now holding our table, you click on run. Basically, Python will show you a snapshot of your data. So this is what your data look like. And it's basically its interactive way. You can even download a snapshot of your data. You can basically sort your data. You can search for your data. You can even do lots of visualization tricks with this data. So basically, it's very interactive thing. Now, let's move forward. In Python, everything has its own code, or let's say everything that you want to achieve, which is unorthodox and unknown, or let's say it's less common. Basically, there is a library to do that. Now, do you guys know the Markov chain or the Markov chain rule, which is basically used for statistical simulation? Well, Python has a library for that as well. You also have heard of Monte Carlo simulation. Well, Python also have a dedicated library for that, but you can also do that manually. Anyway, let's continue. Next thing that I will do is I will make sure that my date is formatted properly. So for this, I will do something like, let's continue, do something like data.index equals to data.date PRD. So by the way, if you don't understand what's happening, it's basically just I am making sure that the date is properly formatted and it's set as the first column, because the plot that we are going to do is basically demands that. So that's a really specialized case. So let me show you. Now, the next thing is just to select a single well. So let me show you. So, sorry, I select a single table. And it's going to be the table that we're interested in. If you're interested in seeing how gas-oil ratio is changing, well, be my guest, select that column. If you're interested in the oil volume or the oil rate that this well is generating per column, or let's say per year, and how it's changing visually, well, you can do that. You can select anything you want, by the way. Everything is flexible. So let me show you. So let's select a single column. So let's call the single equals to data. And we open and close brackets, and then we have the name of the column that we're interested in. So let's say that we want the bore water volume. So let's say that we are creating this calendar to see how water is changing with time per calendar. We will move next and then import the library that's basically responsible for this action, which is called calplot or calendar plot. So it's called import calplot as CP, and then we are just going to create our calendar. So the calendar for this will be, before I show you the calendar, let me show you how the code is going, sorry, how the data is going to look like now. So if we print the data and click on a nice run, you will see now the version of the data. Now the data is just condensed to the data production and just a single parameter. And yes, if you're wondering, yes, this is a univariate analysis. So this is a single variate analysis. So what we are going to do is we're going to start showing this calendar. So if we type CP, which is short for calendar plot, dot calplot or calendar plot, now we only need to feed a single thing, which is the data. And sorry, which is the data, which is called single. Once we click on run, we will get this calendar plot. Anything empty is basically no data presented. And you have this nice color bar that you can basically compare with your data. You can, of course, see that there is some seasonality in production, especially it's basically denoted with these vertical bars of the unified colors. Now, if you're not comfortable with the colors, you can also change that by changing the color map. So let's pass this option. So if we type CMap equals to rainbow, by the way, Python supports lots and lots of color maps. Even you can create color maps of your own. So let's see why this is happening. So let's delete that. Yes, actually, we're actually missing an N. By the way, now do you see those suggestions in red? Those are all the color maps that basically Python is looking at. So let's click on run. Now this is a different color map for our water production. Now the lighter values are the let's say the values with the higher production. Now this is for the water production. Now what happens if you want to do the same thing but for what for oil? Well, you might guess it. Just copy your code and open a new Python cell. So let me show you. Let's clean this up and just paste another Python code. And in this Python code, what I will do is instead of choosing water, I am going to choose gas. Just like this. Only a single thing will change to get your new results. Let's say that we don't want this anymore, or let's say we want to change this to gas. Run this. Yep. Let's delete that. Now we have codes that are conflicting, by the way. There we go. Now this is what our uh, data looks like. It's basically showing us the production for gas. Also, the gas also shows some seasonality. Now let's move forward to another example. Okay, so another example will be done by opening a new Python line. By the way, what you can do is you can just export this example by going to these three lines, which is we call this hamburger button. You go to download, and then you can download this as an HTML, and you can share this with a colleague. But by the way, what your colleague is going to look at is going to be somewhat, let's say, static. But if there is a interactive chart, your colleague will also be able to look at that interactive chart. Now, let me show you another interesting example, which is the ability to create contour and colored contour charts in just a single line of code, which are these plots are not even possible in Excel, at least easily. Now, let's start with reading file. So we're going to read the data. So let's get, sorry, let's get the data from the pressure survey. By the way, for the pressure survey, we also have the data that I will show you that. So read CSV. So since this is a CSV or text file, so let me show you what the data looks like. So this is the pressure survey we have. This is what it looks like. So what we are going to do is we're going to connect this file. It might look messy, but Python will just parse this very, very fast. So we are going to read whatever content this file have into Python, and we'll start to plot that in real. To show you whenever you try to run a particular code. Now, let's move forward and start utilizing this library. Now, one of the very nice things that we can do is basically we can view what columns that this Python code has, which is a very good thing. These are the columns that we have. We have the longitude, the latitude. Basically, we have different things. Now, what I will show you is I will create two different maps based on the same data. The first map is going to be a satellite renderation. The second map is going to be an XY map, basically filled with contour colors. So the first thing that I will do is I will add a new Python code. And in this Python code, what I will be doing is I will be creating our contour map. So contour map equals to Plotly Express, which is the name of the library, and we are going to create a density contour, which is just a colored contour. So for this, we are going to pass our data of pressure, and then we need to decide on the x. So what's going to be our x-axis, which column is going to be y, and which column is going to be z. Basically, z is basically the depth value, not the actual depth, but the depth of the color, or let's say the depth of the contours curves. So this is what it means. Now let's start filling those in. So we will have the y, or the latitude, like this, and we are also going to have the longitude. And for the x, we are going to use the pressure data. So let's use the pressure data, or even you can use even the water depth on these, let's say on these wells. For example, let's select the water depth in meter. This is just going to be an initial chart, by the way. Let me show you. So if we type the name of the chart and then click on run, we will get a dynamic chart that's basically looking like this. And this, I know this missing colors, but this is what the chart looks like. And in order to add that particular option, I will just update the contour with the proper colorings like this, and click on run. There we go. Now this is what your contours look like. Of course, this is just two lines. Well, the first line is actually the line that's basically responsible for plotting, but the second one is just an options line, or let's say basically it updates your chart. So this is the first chart. Basically it's a contour map. Basically, you can zoom into any portion of this. Of course, you can also show the locations of the wells on top of this contour. You can change the color map. You can change anything you want in this. Let me show you another version, which is going to be a heat map, or same thing close to a density map, but it's going to be an actual satellite renderation. So let me show you. So I will create a satellite map. I will call this a heat map equals to plotly express dot density map box, which is going to be an actual satellite. And for this, what we need is we need the pressure, and also we need the x and y. But this time the x and y is not called x and y. It's called the longitude and the latitude, because we are creating geographical maps. So what we need is we need the latitude equals to something, which is one of the column names, and we need the longitude, which is also going to equal something, and of course the z is going to be the same. So I will copy the z, and later I will change it. So and for the x and y, for the longitude and the latitude, I will just copy and paste these column names, just like this. And let's do one thing. Let's make sure that everything is in single line, so you can see how this is going to work. And final thing is map box style, which is going to be how you want to view your, let's say, the map. What's the style you want? Maybe you want street, maybe you want satellite renderation, maybe you want dark street. Basically, we have lots of things that we can offer. So one of the things, by the way, these are already exists online, so you can look through these in the documentation. We have OpenStreetMap. We can click on run. Yeah, actually, we have the longitude and the latitude not set up properly. So let's make sure that these are properly set up. There we go. Now this is what the maps look like. So we can zoom in, we can zoom out. Basically, this is a heat map, what our field looks like. And of course, this is just the water depth. You can switch the water depth to anything you want. For example, you can switch this to an overpressurization. You can switch this to liquid contact. You can switch this to anything you want, by the way. Let's say that we want to see, for example, the overpressure flag. So we will paste overpressure instead of the water depth and click on nice run. There we go. Now this is what our overpressure looks like. And it's basically an interactive map. You can zoom in, you can zoom out, even you can change or scroll to anything you want. Now, one final thing that left, let me show you how we can share this rather simple report. So what I will do is I will go to these three buttons and then I will click download and then I will download this as HTML. So we will click on HTML. It says that your notebook has to be named. So let's call this webinar by PA. So once we do that, we can go ahead download and then download as HTML. So let's see webinar. So let's save now. There we go. Now it's saved. Let me show you if we open this on the internet. There we go. This is what it's going to look like. If we open this on the browser, this is what basically it's going to look like. Basically, you will have the code showing up. Also, you can create different types of exports. For example, you can export without the code, just the HTML. Maybe you want to preserve your code for yourself, so you can download as HTML without the code. And basically, this is what it's going to look like. Plus, what you can do is you can also view other exports that you have made previously. For example, we have this export. Basically, we have done. This is the chart, and these are basically the codes that are corresponding to it. And basically, whatever you do is basically the user that you're sharing this with is going to get. For example, and he can or she can even fully interact with the chart that you're sending, basically. And they can also see the analysis that you have done. They can interact with it. Basically, they can do anything they want with it as if they were writing the code. Thank you so much for joining in. Hopefully, you did not get bored with this session. And over to you, Nikhil.